So what we're going to do, we're going to talk about something called magnetic flux and magnetic flux linkage. Now, first of all, recall that magnetic flux density is denoted by the letter B, measured, of course, in Teslas. And if we want to now do something called magnetic flux, magnetic flux denoted by the small letter phi, is B perpendicular times A. Well, I've already written it here. So what exactly is this? Well, this is actually the amount of, well, you can think of it as the amount of flux density that you can capture in a certain amount of area. And what is this B perpendicular? Well, consider the given area here, this little 3D drawing that I've drawn. Okay, let this area be A. And if I have a certain magnetic flux density going in this direction, then what we need to do, we need to resolve it into the components that are, number one, parallel to the plane of this area and perpendicular to the plane of this area. And of course, B perpendicular will be this component over here, which we will then use to multiply to the area to get the magnetic flux captured in this area. So what is very important to understand is that only the perpendicular component of the magnetic flux density to the area is contributing to the flux captured. Is this okay? Now, if we understand this, then we can go on to something called the magnetic flux linkage. And this is quite easy to understand because this is denoted by capital phi and is simply the number of turns in your coil, which is creating this area over here, multiplied by the flux that you have calculated earlier on. And so it is quite common that these areas that we are talking about consist of usually a numerous number of turns of coil. Okay, and so for example, if you have 30 turns, then N is 30, and you multiply by the flux that you have captured in that area. Yes, and also the unit of flux and flux linkage is the Weber. W